Yeah. Hello everyone. Today I'm going to show you a powerful Python script that automatically detects thousands of messy bank account transactions to customer list. So let's start with the data that we have. So this is the data that we have customers table where we'll be having the invoice customer name, then the phone number and bank address, and then the UPI handle that we have. So our task is to uh, map everything that is there in the customer list to this transaction table. And initially, what I thought was, so in this description we have, we are able to see in the description we were able to see few strings or names that we have here, such as here KKB Trans or A Arjuna Mahalingam. It is either to NEFT or IMS or if you we have is UPI. So in this UPI we'll be able to see the name, and in NEFT also I think we'll be able to see the name. And yeah, this is the but yeah, NEFT we won't be able to see the exact name. It's just some company number that we have here. So this is the problem that we have. So here, what I found a solution is, which is able to solve this problem, is something called has an hybrid approach, where what we do is we have two methodologies and we combine two of it. So one is going to be exact matching here. So exact matching is going to be for the phone numbers and the UPI handles that we have. So if the phone number is already there, so this is going to be the phone numbers and the UPIs. So these two, if we already have these both, so we can directly match it and take it out. This is the first thing. If it is not there, so only the name is there or anything is given, we do something called as and semantic similarity search, where I have used a library called uh, FICE, Facebook A similarity search, where I have taken an embedding model where it converts every tokens into embeddings, and then a query is being generated where it just has an how much similarity it is, it calculates with the help of something called as cosine similarity. This is going to be the main function, exact semantic queries, where I have take the queries. It is taking a L2 norm, the cosine similarity between each of the contexts that we have. And once a query is being given, it normalizes and then it constructs a vector DB that we have as every invoice name, bank details, everything in the customer is being made into an vector DB, and in that we index it and then we search an particular thing that we have and how much close it is to the uh, original name. It just takes out and then it prints away. So this is going to be the overall ID that we have, and it has pretty worked. It is almost around 70% have been come correct. And here what I've made is I've kept a threshold of 56. So I was doing few the trial and error methods where first I kept it as 70, but then the most of the values were from 50 to 75 range only. So slowly did a trial and error, and then I found out to be that this 56 value was a perfect value where it could not give us the false positives that we have, any other names we have. And I also found that in the data that we have, the customers, few of the customers aren't they're not associated with the direct transactions that we have, and in the transactions we are not having those customers direct customers that we have. So if you're the problem in the data set is also there, but then this has compromised these problems and had made into an the matchable thing. So this is the final Excel sheet that we have. So in the transaction table, if we go here, so uh, let's say here the name is given as, the description is given as KL Bhaskaran. It is able to find that Usha Bhaskaran is going to be the name and the five index that we have, the value, the score that we have. So let's take a higher value. It's 74. So that should be obviously right? So here you could say that Lakshmi is directly given, and it also exists a name in the customer rate. It's called Lakshmi Sankar. So that is something that it is able to predict of. Here it is 75. So it's Nandini Kumar. When you go to description, it's added as Nandini. So so the scores. So this one when it's 100, where this works out in the first method that we have, the direct search, where Meenakshi Vijayanand, where it is able to find directly the number that we have, the UPI that we have here. This Amupal IC was actually in the customer's ID itself as an UPI handle. So this almost was able to find out. And coming to the summary part, we have here around 76% was able to find, and non-this were around 23%. And in the overall score that we have, here we have around very good searches 66 and almost good is 98. And this okay, finance was 281, and this 295 is actually a big number, which it consists of a huge percentage. But then overall, when I checked it at like one on ones, it's almost able to predict it properly. So this is the overall assignment I have did completed, and this is the results I'm able to produce, and all the code snippets and everything is being provided in the GitHub. I'll just share it with it too. Thank you.